Hello guys, this is section 4.1 notes. The essential question, or what you should be able to do when you finish, is translate a figure in a coordinate plane. Just a reminder, this is a coordinate plane. Some people call it a graph. The official term for it is a coordinate plane. Okay. Well, here we go. The first thing we're going to talk about is vectors. So this picture right here is a vector. It's got an initial point, P. That's where it starts. And then it's got a terminal point here at Q, and that's where it stops. To name a vector, you start at your initial point. That's your first letter. And then you go to the terminal point, your end point, and that's your second letter. The symbol we use is a line with a half arrow. You can also just name this vector PQ. Now, all vectors can be written in component form. And basically, component form is just telling the directions to get from P to Q. So if you look here, you have to go 5 units right and 3 units up. Well, we would write that as 5, because we're talking about our x here. Positive 5 is right. And then up 3 is with the y. Now we do these little, I believe they're called braces. I could be wrong about that, but I think they're called braces. And there we go. There's your component form of your vector. So let's look at some examples of naming and writing the component form. So in this diagram, name the vector and write its component form. Well, your initial is J, goes to K, so this is vector JK. Now, to write its component form, remember, that's kind of just saying the directions to get from J to K. Well, it looks like we're going right 1, 2, 3. So right 3, up 1, 2, 3, 4. So there's my component form. It's vector JK because it starts at J, goes to K. You go right 3, up 4 to get from J to K. So there's your component form. Now, a translation, it moves every point of your picture in the same direction. Now, the rule kind of just looks like this. X comma Y. Our component form can be rewritten as X plus some letter and Y plus some letter B. Now, if this number right here is positive, we move right. If it's negative, we move left. And then same thing with the B, but since we're talking about Y's, a positive B means move up, and a negative B means move down. So let's look at that, because translations, we're going to see them a lot in this chapter. Okay, so it says the vertices of ABC are 0, 3, 2, 4, 1, 0. Translate this triangle using the vector 5, negative 1. Well, to do that, I'm going to go ahead and write out each of my points. So 0, 3, 2, 4, 1, 0. I'm going to rewrite this component form into a rule. So xy becomes x plus 5, comma, y minus 1. So notice the 5 and the 5, the negative 1 and the negative 1. So I do exactly what this says. I add 5 to my x's. To all of them, actually. Then I subtract 1 from my y's. Now, something we'll use a lot is what we call primes. It tells us that a transformation's happened. So we call this new point A prime, this one B prime, and this one C prime. And now the last thing we need to do is plot these points. So 0, 3 is A, 2, 4 is B, and 1, 0 is C. Then we've got 5, 2, that's A prime, 7, 3 is B prime, and 6, negative 1 is C prime. And there we go. We're done. So that's a translation. All right. Now we might have to find a rule to go from ABC to A prime, B prime, C prime. So we're going from the blue to the red. Let's see. It looks like we're going 1, 2, 3, 4. So left 4, and then up 1. So we want to write this as a rule. So we're going to go x comma y becomes x minus 4 for the left, y plus 1 for the up. And there's our answer. We're done. Now if they want you to put this in component form, that's negative 4, comma 1. So this is rule. Some people call this translation form. And this is component, also known as vector form. So make sure you know which way they want it. All right, let's do a little bit of practice. Name this vector and write its component form. So b to k, so our vector is b, k. Looks like we're going 1, 2, 3, 4, 5 left, so that's negative 5, comma, up 2, 2. And at any time you can pause this video, try it on your own, and then see what I get and compare. So the vertices are at 2, 2, 5, 3, and 9, 1. Use this vector, so we got to change this into a rule. So x comma y becomes x minus 2, y plus 6, because of the negative 2 in the x spot and the 6 in the y spot. So we're going to minus 2, add 6. Minus 2, add 6, minus 2, add 6. 2 minus 2 is 0, 2 plus 6 is 8. 5 minus 2 is 3, 3 plus 6 is 9. 9 minus 2 is 7, 1 plus 6 is 7. Now we need to mark these so we know a transformation has happened. So L prime, M prime, N prime. Then you also need to make sure you graph it. But I'm not going to waste our time by graphing that. You should, hopefully, remember how to graph. So now we've got these 4 points. They want us to use these rules to move them. So A is -1, 2. B is -1, 5. C is 4, 6. And D is 4, 2. The rule says add 3 to all of your x's and subtract 1 from each of your y's. All right, that's 2, 1, 2, 4, 7, 5, and 7, 1. Make sure to mark these new points so we know a transformation happened. So it's A prime, B prime, C prime, D prime. And then you would graph them. But again, I don't really want to emphasize graphing in this video. I want to more talk about how to use the rules. So I'm going to skip the graphing. Make sure you are graphing. All right, this time we have 2 translations happening. So we've got to make sure we look at that. And then we're about done. So I've got R, which is -8, 5, and S, which is -6, 8. Rule says add 5 to your x's, subtract 2 from your y's. So -3, 3, -1, 6. So that's R prime, S prime. Then we do it a second time, where it says subtract 4 from your x's and subtract 2 from your y's. So -7, 1, -5, 4. Since this is the second transformation, we call this R double prime or R second prime, and S double prime or S second prime. Make sure you plot all these points. Maybe I will this time just for the extra practice. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. So there's R. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. -6, 8. There's S. Then we have -3, 3 for R prime, and -1, 1, 2, 3, 4, 5, 6 for S prime. Then last one, we've got -7, 1 for R double prime, and -1, 2, 3, 4, 5, 1, 2, 3, 4 for S double prime. And there we go. Now there's some more examples we can look at, but it's kind of the same thing again. So hopefully this one example is enough for you. And that's section 4.1, translations with vertexes. So hope you enjoyed it, and I'll see you next time for another notes video.